Okay, we're going to talk about inverses today. What is an inverse? An inverse is a reflection of x's and y's. That's a technical, not very technical, but somewhat technical. It's just a reflection of x's and y's. If you were to go on urbandictionary.com, you'd probably read that it is switch the x's and y's. It's the same idea. So that's what you want to use to figure it out. Just when you switch. Okay? So let's talk about this first function right here. I'll do the inverse right below it. So we have a function x plus 4. Not thinking about inverse right now, just plug in a 1. If you plug in a 1, what do you get? Plug in a 2, what do you get? Plug in a 3. Plug in a 4. Oh, that was real hard. The inverse would give you values of not 1, 5, but 5, 1. Not 2, 6, but 6, 2. Not 3, 7, but 7, 3. Not 4, 8, but 8, 4. Oh, that was really tough. So the domain of the original is equal to the blank of the inverse of the range. You really just, because domain is x, range is y, all you do is you just flip-flop them. So the range of the original is the domain of the inverse. Yeah. That's okay. Is that better? Yeah. That better? Perfect. Alright. I don't know if I can do this the whole time. Just a little bit. Is that good? Knowing the blurriness? It's okay. You know, there's a seat right here you can sit in. Oh, okay, so you don't care about that much. Right, now I can't even read it, it's too big. The inverse functions, f and f inverse, have the effect of undoing each other. Essentially, like, what's the inverse of it? Adding something, subtracting. I've heard me say that before when we're solving. The inverse of multiplying is dividing. So that's when you're solving for like x. You're just always doing inverse operations of each other. Right, I do need to zoom out for this next one. So, find the inverse of f of x, which is root x minus 4, and then verify that they are equal to the identity function. Okay, so to find the inverse, all you're going to do is you are going to, step 1 is switch x and y. Then you're going to solve for the new y. Okay, so when I switch x and y, well, Coach Member, I don't see a y up there. What is y? It's f of x. It's the same thing, alright? So this is really like a y. Same thing. So I'm going to switch them. So it's going to become x equals root y minus 4. So we're going to solve for the new y. What's the first operation? What's the inverse operation of a square root? Squaring. You're going to square each side. So you can get x squared equals y plus 4. Now what do? You're just going to subtract 4. So you're going to get x squared minus 4 equals y. So now to write this out technically, it would be f inverse of x is equal to x squared minus 4. Plus 4. Plus 4? Oh, because over here I wrote the wrong thing the entire time. And then so that, yeah. Typo. We call those typos in my business. Alright, we good? That's just solving for the inverse. I don't really need to verify it. It's all good. Okay, number 2. Which of these functions is the inverse? So, how do you know? Oh, you just switch. So you can do that in your head? No. No! Quite smart people. I can't do it that fast. I couldn't do that fast either, to be honest with you. I would actually show all the work. So I'll show all the work. So we're going to get x equals 7y plus 4. So we subtract the 4, divide by the 7. So it's the first one then, you're saying? So yeah, I agree. I kind of talked about this one. The graph's inverse is kind of the technicalities of it. So if you have a point AB, the inverse is just BA. And it's a reflection over the line y equals x. That's the parent function. I asked you about it a couple classes ago, and you said it was a diagonal line through the origin, which is true. Alright, so it's just a line of symmetry. You can just reflect it over that diagonal line. Alright, so number 3, sketch the graphs of the inverse functions f and f inverse on the same coordinate axis and show that they're a reflection of each other. I guess by showing, you just need to draw that dotted line. So let's go ahead and graph these guys together. So let's do f of x first. If you want to do it, I'll do it in different colors. You don't have to. I will, just so you can see the difference. So I'll do the f of x in blue. It's a line. Who remembers how to graph a line? Nobody? Oh, we're in trouble. Let's start with the y-intercept first. What's the y-intercept? -1. I'm going to rise 4 and then over 1, always to the right. And then you go the opposite way. And if you had a ruler, I don't. I have a folder. Same thing, right? Aha. That's straight. Please label it. You can just label it like F, just like that, and you're good. For the F inverse, it's the same thing as 1/4 x plus 1/4. You agree? Okay, now the y-intercept is 1/4, but that is like really difficult. It's easier just to find an actual point that's integers on here first, and then from there you can do the slope, because you don't always need to start from the y-intercept. That's just the easiest one to find. But in this case, the y-intercept of 1/4, that's kind of lame. What's a better x value that you want to start with? X equals what? 2 is difficult, because it's going to be 3/4. Let's start with 3. So x equals 3, what do I get? 1. So when x is equal to 3, again, I'm just plugging in 3 here. 3 plus 1 is 4/4 is 1. That's a nice integer. Now, from there, I can do my rise over run of 1/4. It's just much easier to do. Could you start from 1/4? Yeah, but my brain can't handle that. So draw your straight line. I'm going to label that F inverse. Okay, so here's the line y equals x, and it's a reflection of this. It should be pretty gosh darn accurate because I drew a straight line. So that's a perfect reflection of the blue and the red over that. If it's not, don't be so picky. Alright, any questions on this whatsoever? What inverses are and stuff like that? No. Okay. Let's move on. Sketch the graphs of the inverse function. So we get the f and then the f inverse on the coordinate system, and then show how the graphs are reflections of each other. So first off, look at the original function. It's restricted. It has to be restricted to be an inverse to the square root. Why does it have to be restricted? Because the square root is kind of limited. It only is half a parabola, so you have to restrict the parabola for it to be an inverse. Okay? If you don't restrict the parabola, then it's not an inverse. So let's go ahead and do this. So I'll do the original in blue. So help me out. How do I want to graph this? Anybody know how to graph parabola? If you really have no clue, just start plugging in 0, then 1, then 2, then 3. Hey, let's just do that actually. What's 0 squared plus 1? 1. By the way, the vertex is at 1, and from there you can go like over 1, up 1, over 2, up 4. But anyway, plug in a 1. 2, plug in a 3. No, sorry, a 2. I skipped 1. Plug in a 2. 2 squared. Yeah, 5. And the next one is going to be 10, right? I'll just take the parent function of the parabola. I just pushed everything up 1. So this is my best drawing I can do. Don't criticize me. Can't handle the pressure. Okay, so now to do the inverse. I mean, really, there's 2 ways you could actually do this. If you wanted to, if you're like, I don't know how to graph that, I'm lost, couldn't you just take every blue point and just switch it? What's the first blue point? 0, 1. Switch it. 1, 0. Totally lost if you don't know how to graph it. Alright? Or you know that the parent function of a square root, you're just pushing it to the right one. The same thing. So whatever floats your boat. Alright, and then voila. And we can verify that the red one is correct, because, like, first off, you can't plug in a 0 for x because it's imaginary. So the first thing you can plug in is a 1. Square root of 1 is 0. You'd plug in a 2. Square root of 2 minus 1 is 1. And you can plug in a, well, to pick a smart number that gives you an integer. So just kind of go from there. Hey, so a one-to-one function. It's the horizontal line test for inverse functions. A function f has an inverse function if and only if it has no horizontal line intersects the graph of f at more than one point. Okay, so function f has an inverse if it passes if the original passes the horizontal line test. Okay, that's to make sure that the inverse is a function. So a parabola. Let's real quick look at a parabola. Does the parabola pass the horizontal line test, where it only needs to touch one time? Does it pass it? No, it fails miserably. All right, fails the same test like my preschooler was sharing. It's gonna fail it miserably. Okay, boom. So its inverse is not a function. Yeah, they all have inverses. It's an inverse relation, but the inverse is not a function. Okay, it needs to pass the horizontal line test in order for the inverse to have a function. And actually, a function is 1-to-1 if its inverse is a function and the original is a function. So if it's 1-to-1, that means it passes the vertical and horizontal line test. That means that there's no repeating x's, no repeating y's whatsoever. It's 1-to-1. Because there's 1 and 1. There's one input, one output for everything. Oh, the next page is what does it mean? Well, I kind of just said it. Y values cannot repeat. Obviously, X values can't repeat because X values repeat. It's not even a function. All right. So let's go ahead and graph this guy right here, this f of x, and then let's use the horizontal line test to determine whether the function has an inverse. Okay, so I'm going to rewrite this so it's easier to graph. I'm going to rewrite this as negative 1/2 x plus 3/2. Are we cool with that? Anybody confused how I did that? How I figured it out? I literally just when I'm graphing lines, I like to have it in mx plus b form. So I just look what's the coefficient in front of the x. It's a negative 1, and it's all over 2, so it's negative 1/2. So this is another one of those guys that I'm not going to really like graphing from the y-intercept. What's a better point? 1. You want to pick 1? Doesn't matter. X equals 1. When x equals 1, what's my function at? 1. And then from there, I can use my slope of down 1 over 2. I mean, you don't need a straight edge. I mean, I'm totally cool with it. I'm only doing this because this is on video notes. I'm supposed to make it look good. So people from Sweden can watch my video and be like, whoa, the teacher knows what he's doing. You're joking? I have looked at the, when I was at my old school, sometimes I just look at the analytics of it to see, who's like watching it, and one of them was like, nationally, and it was like 97% United States, and then 3% or 3% other. So I was like, that's interesting. Well, people from Sweden, what another country I couldn't pronounce, it was somewhere in Africa, and then there was one in Asia somewhere, I forgot which one it was, but there's like 3 different countries who are watching my videos. I don't know why. That's a fun fact. That's not on the test, so don't worry about it. Okay, does this pass the horizontal line test? No matter any horizontal line I draw, it will only intersect once. Does it pass? Yes. So does this have an inverse? So yes, this has an inverse. Has an inverse. I'm going to say function because everything is inverse. If it's a function, it's different. All right. Next one. Are the given functions 1-to-1? Do they have an inverse function? If so, find the inverse. You don't have to graph them, but I'll graph them for you. So, hey, we remember this guy here, right? X cubed. We graphed him the other day, and we loved him so much. I don't know why to him, but it just is. So, is the function 1-to-1? Does it pass the vertical line test and the horizontal line test? Yes. So this would say yes. 1-to-1. They have an inverse function. Yes, inverse. I think those questions are very repetitive. So find the inverse. So what's the inverse of x cubed? It's actually cubed root of x. The inverse is just cubed root of x. If you want to do it the long way, you can just reverse the x, switch the x and the y, and solve for the y. You would just take the cubed root of it. And then, I don't know, do we really need to graph it? We just found it. Do you want to graph it or no? Yes or no? No. We want to do as little work as possible. Okay. I'm cool with that. B. So this is the parent function moved down to. That's enough. I don't need to draw that many points. You get the idea. Is this a 1-to-1 function? Doesn't pass the vertical line test and the horizontal line test. Alright? So, I mean, it could be a one-to-one relation, just not a one-to-one function. So I only care about function. So this is a big old no. What does it fail? Okay, part C says do the same thing, but only when x is bigger than 0. Is this one good? Yes. So it's 1 to 1, and then inverse function. So you can have a relation that is essentially a one-to-one function needs to have an inverse function. It's just when we start talking about relations. Relations can fail as many tests, it doesn't matter. So like a one-to-one relation only needs to pass the horizontal line test. Which to me, I mean, it's like repetitive to me because we're doing functions only. So. Alright. Oh, it says find the inverse. This is a good one to find the inverse of. So we'll do all the work here. So let's find the inverse. So how do I find the inverse of C? So we're going to get x equals y squared minus 2. Now what? Plus 2 on each side. Now what? Square root it. Now this is where it's going to be kind of like, huh? Shouldn't this be plus or minus? Don't write it down, but shouldn't this be plus or minus? Yes, it should be, but why is it not? We already limited the domain. The x's have to be only positive, or to the right of the vertex, in this case. So I only care about the positive. Okay? Likewise, the inverse of this would have been the plus or minus version, which is not a function. It's a relation. It's not a function, though. So, quick heads up on that. Alright. Next here is finding inverses. I'm going to go through these really, really fast because I like those things really, really fast. So, switch the x's and the y's. So, we're going to x equals negative 4y minus 9. This is old stuff to you. We just did it. X plus 9 equals negative 4y. Divide by negative 4. By the way, it's illegal to keep that negative in the bottom. That's not very simplified. So you can't leave it like that and going, yeah, I'm done. You can put the negative in front if you want. Negative x plus 9 over 4. That's totally legal. That's fine. You can do that. Or you can bring the negative upstairs and make everything negative. So this is the same thing as this. Alright. This negative just means that, hey, the whole fraction is negative. This one right here just means, oh, the top is negative. Does that make sense? Like, huh? It's notation. I'm just trying to make sure our notation's good. If you like just to put all the negatives upstairs, be my guest. So, this is the inverse. Number 8. Why don't you start number 8 on your own? See if you can figure this one out. Start 8 on your own. Oh, then we're done. So, yeah, try 8. Anybody else get x cubed minus 10? Questions, comments, concerns? So now we're all experts on inverses.
Yeah, I guess, maybe, I don't know.